Good morning everyone. This is Soumyaranjan Nahak. Welcome to my channel Renu Ratna Pathshala. So today we are going to study about epsilon NFA. Epsilon NFA is a part of NFA and it belongs to the without output finite automata. We had already discussed about the finite automata categorization. So I want to recall the finite automata categorization. Finite automata is of two types. One is with output, another one is without output. So in the side of without output, we had already discussed about the DFA, NFA. Now we will discuss about the epsilon NFA. And this is the categorization of finite automata. And in the side of with output, we will get millimachine and Murray machine. So we got the idea about the epsilon NFA. Epsilon NFA is a part of finite automata of the category without output. So I will erase and I will explain what is epsilon NFA. Epsilon means empty. It means empty. If we are not giving any kind of input, then it is known as epsilon. In this finite automata, we are not giving any type of input value or symbol. In case of epsilon NFA, we are not giving any kind of symbols as a input, and it is a part of NFA. Part of NFA. So this is the definition of epsilon NFA. So write down. Then after we will move toward the tuples. It's like NFA, DFA, it also contains 5 tuples. All tuples are similar with each other, but only one tuple, delta, is dissimilar with DFA delta or transition function and NFA delta or transition function. So there are 5 tuples. First one is Q, finite set of state, Q0, initial state, sigma, number of input symbol, F, final number of final state, and last tuple is transition function. So these are the 5 tuples of epsilon NFA. Capital Q represent finite set of states. Q0 represent initial state, sigma represent number of input symbols, delta represent transition function, and capital F represent number of final state. My example will be, so this is the string which should have to accepted by a machine which is belong to the epsilon NFA. So first we will try to understand which kind of symbols are used here. Here we are used 0 plus 1 clean closure. 1 clean closure means epsilon is also comprised here 1, 1, 1, 1, 1, 1, and it's like it infinite number of 1 can create a string. So these two symbols are used in this question. So initially we will implement or we will create Q0 as an initial state. Then after we will implement epsilon. Epsilon means nothing, empty input or empty symbol. For 0, we accept or use or construct a transition. 0 is done. Then after we will move toward the 1 clean closure. For 1 clean closure, we must have to use an epsilon and other strings. So epsilons is directly go to the epsilon. This is the transition where epsilon exists. This is the transition where 1 exists. For other string, we will create a transition. So for other string, we will create transition, some transitions, and for some transitions, we will create state also. So here we will implement epsilon, here we implement 1, here we implement epsilon. And here in this machine, we are getting a string or we are getting a point where one string is accepted, that is 0 is accepted by this machine, 1 is accepted by this machine, epsilon is accepted by this machine. But condition is we should have to accept all the string which has originated according to the questions. So for 1 we create, we use 1 in this transition and we accepted in destination state. For double 1, how we will accept for double 1? So here we will implement another transition which will come from the Q5 and it will go to the Q4. Here we will use epsilon. Epsilon means empty input. So for this condition, according to the questions, the machine has been created. And for 0, this transition is occurred. For epsilon, this transition has been made. For 1, this transition epsilon 1 1 1 has originated. For double 1, how we will accept it? Epsilon 1 and we have to create double 1, not single 1. Here we are creating single 1. Here we are creating single 1, but we have to accept double 1. So we will go Q4 to Q5 by using single 1, and for another one we will move backward to the Q4, means we will move back to the Q4, then after we will move Q5 by using another one, because this is a kind of looping transition. 1 1 for one transition we will get 1, for another transition we will move to the Q4, Q5 to Q4, then we will move to the Q5 for another one. For 3 1 1 1 1 1 Then after we will move. Then after we will move back to the Q4. Another one for 3 ones, 1, 1, 1. It's like it infinite number of 1 can be created, or this question is being accepted by this machine. So thank you.